Hi, we're back talking about maximums and minimums. And as it turns out, we started looking at some notes for the extreme value theorem last video. That just means on any closed interval, if it's a continuous graph or continuous function, there's got to be a highest and lowest point. A few relevant facts I want to put up there. You might have more than one highest and lowest point. The sine graph that we had in completion before has an infinite number of maximums, both absolute and local, and minimums too. I also want to throw out the idea that the highest or lowest point might just be the endpoint of this. Our cubic function, when we're looking on this interval, normally the entire cubic would go on forever. There is no absolute maximum or absolute minimum. But if we look on just an interval, it is just the endpoint, not necessarily the top or bottom of a curve. Okay? And for a constant function or a linear function, the highest points are always going to wind up being basically the endpoints that are there. I didn't even mention this, but for a constant function, a horizontal line, every single point on there is the absolute maximum and the absolute minimum. An absolutely confusing situation to be in. But technically, it is true. By the way, here's a nice long list of some mathy type definitions. What is a maximum or a minimum? Well, if this point is on an interval, the y coordinate at that point is less than or equal to any other point on there, or greater than or equal to any other point on there. That's a max or a min. What does it mean when it's relative? Well, that just means it's the highest point on an open interval, or the lowest point for minimums. And what does it even mean to be increasing? Well, this isn't what we're talking about, but it's a nice time to introduce this definition. As your x values get larger, so do your y values. That means it's increasing. If your x values are getting bigger, then your y values are decreasing. These are kind of the mathy ways that we would define these ideas. Simple ideas that you probably already know, but once again, it's nice to put a definition with it and to make it clear. So here's the steps for actually finding those highest and lowest points, the extreme values as we call it. First, we're looking at an interval from A to B. Second, you need to find all the critical values. Critical values, there's a very simple definition for this. Any point where the derivative equals 0 or it's undefined. I'll repeat that. A critical value is any point where the derivative is 0 or undefined. Next, I want you to find the y coordinates or the function value at each of those critical points, and then find the y value or function value at each of the endpoints. I'm leaving out an important step, which is whichever has the biggest y value, that's your maximum. Whichever has the smallest y value, that's your minimum. We can roll it from there. Well, let's take a look at these examples up here. So first off, I took the derivative of each of my four functions up here. And why would I even worry about the derivative? Well, if you haven't noticed yet, the slope of the tangent line at a maximum is always 0. The only time that might differ is if you have a cusp, a corner, or something unusual like that, where the slope of the derivative at those points would be undefined. So when I look at these derivatives, I'm actually going to set these equal to 0. This one I look at is a quadratic. Is there any point where it is undefined? No. Neither is there a point here or here, but in this one, it would be undefined if x was 0. So that's one of our critical values. Next, I'll go ahead and set all these derivatives equal to 0 and see what x coordinates make the slope 0. Now that I have those critical values, and by the way, this graph looks a little off now. Where the highest point's really at -1 and 1. Now they're at some place called 2 root 3 over 3. Close to 1. Cosine equals 0 several different places, but on this interval, there are only 2 locations. Down here, we have one point where it was undefined, but there's nothing that makes this derivative equal 0. And finally, since the last one has a slope of -1/2 everywhere, there are no critical values. For this first one, I plugged in the endpoints and the critical values to find the y values. The biggest y value is the maximum, the smallest y value is the minimum.